For thousands of years, the night sky was our shared storybook, our map, and our greatest mystery. But for most of us today, that book has been slammed shut. A luminous fog we call light pollution is erasing the stars. It's estimated that over 80% of the world's population lives under skies so bright that our own galaxy, the Milky Way, has become a myth for a third of humanity. This isn't just a loss of a beautiful view. For astronomers, it's like going blind. The ancient light from distant galaxies, which has traveled across eons to reach us, is being drowned out by the glare of our own cities. The night sky is getting brighter by as much as 10% every single year, relentlessly closing our window to the cosmos. But as our cities glow brighter, a quiet and ingenious revolution is taking place in the planet's last pockets of darkness. A new breed of astronomical sanctuary is emerging, the remote telescope farm. These facilities are technological oases, housing robotic telescopes that can be controlled by anyone with an internet connection, from anywhere in the world. This is the story of how we are escaping the glow and reclaiming our view of the universe, one pixel at a time. To understand the solution, you have to grasp the problem. Light pollution isn't just light at night. It's the excessive and misdirected glow from unshielded streetlights, floodlit buildings, and glowing billboards. This wasted light scatters in the atmosphere, creating a luminous blanket called sky glow. For astronomy, the effect is devastating. The faintest objects, like distant nebulae, are only slightly brighter than the natural darkness. When sky glow artificially brightens that background, the contrast is lost, and those objects simply disappear. It's like trying to hear a whisper in a packed stadium. Think about the difference in the sky during a major power outage. Suddenly, where only a handful of stars were visible, the brilliant, star-choked band of the Milky Way appears. That's what we're losing every single night. The damage goes even deeper. Astronomers use a technique called spectroscopy to split starlight into a rainbow of colors, revealing fingerprints of chemical elements. This tells us a star's composition, temperature, and motion. But common street lights, like sodium and mercury vapor lamps, produce their own distinct spectral lines, which contaminate the light from stars and galaxies. It's like trying to read a book where someone has scribbled all over the pages. The problem is so severe that 2/3 of the world's major professional observatories are already impacted by light pollution beyond the recommended safety limits. This compromises our ability to monitor potentially hazardous asteroids, study the explosive deaths of stars, and search for signs of life on other worlds. It's a profound cultural loss, too. The International Astronomical Union has declared the right to starlight as a universal human right, a heritage being erased for future generations. In the face of this encroaching artificial twilight, a powerful counter-movement has been born, not through protest, but through innovation. Remote telescope farms are a direct and brilliant response to light pollution. The concept is revolutionary. If you can't get away from the city lights, send your telescope there instead. These are commercial facilities built in the most astronomically perfect locations on Earth. Places like the high deserts of Chile, the mountains of Spain, and the vast plains of Texas. These sites are chosen for high altitude, dry weather with hundreds of clear nights a year, and most importantly, extreme darkness, rated as Bortle Class 1, the darkest possible. There are two main ways to use them. The first is telescope hosting. You buy your own telescope and astrophotography gear, ship it to the facility, and their on-site technicians install it on a permanent pier inside a protective observatory. For a monthly fee, the farm provides power, security, and high-speed internet. You can then log in from your laptop in, say, London or Tokyo, and operate your telescope under perfect skies. The second model is telescope rental. For those who don't own high-end gear, facilities like iTelescope or Telescope Live offer subscriptions to a whole network of pre-installed, research-grade telescopes around the globe. You can book time on an instrument in Australia, to image the southern sky, then switch to one in Spain for a northern target, all from your computer. The benefits are transformative. The frustration of being clouded out is nearly eliminated. The tedious work of setting up and tearing down heavy equipment every night is gone. Most profoundly, it democratizes access to the pristine skies that were once the exclusive domain of professional astronomers. A hobbyist in a light-swamped apartment can now produce images of faint galactic nebulae with a clarity that rivals professional observatories of a previous generation. The magic of a remote farm lies in its technology. These aren't just telescopes with webcams. They are fully robotic observatories. The core is a computerized go-to mount that can be controlled by software to point anywhere in the sky with high precision. The camera is a specialized, cooled astronomy camera that reduces electronic noise for long exposures. Everything an astronomer would do by hand is motorized. A motorized focuser makes tiny adjustments to keep stars tack sharp as the temperature changes. An autoguider locks onto a star and sends constant, minute corrections to the mount, ensuring perfect tracking for hours. An instrument rotator can turn the camera to frame a target perfectly. This hardware orchestra is conducted by powerful software like NINA, which stands for Nighttime Imaging in Astronomy. An astronomer can create a detailed plan for the entire night. For example, wait until dark, move to the Andromeda Galaxy, take 35-minute pictures through one filter, then 15 pictures each through red, green, and blue filters, and then move on to the next target. The user connects to the on-site computer using remote desktop software, giving them full control. But what happens if the weather turns bad? The most critical component is the safety system. Every facility has a sophisticated weather station, like the AAG CloudWatcher, that constantly monitors for rain, clouds, high winds, and humidity. If any of these cross a safety threshold, if a single raindrop is detected or winds get too strong, the system automatically triggers an emergency shutdown. It parks the telescope and closes the observatory roof, protecting thousands of dollars of equipment. This means an astrophotographer in New York can go to sleep peacefully while their telescope works all night under the dark skies of Texas, knowing their gear is safe. These dark sky havens are doing more than just helping hobbyists. They are revolutionizing education and scientific discovery. In the classroom, astronomy is no longer just a textbook subject. Networks like Skynet, based at the University of North Carolina, provide free access to over 20 robotic telescopes for some 40,000 students. Undergraduates can use the network to collect their own data, reproducing some of the greatest discoveries in astronomy and learning what it truly means to be a scientist. The line between amateur and professional is also blurring, thanks to citizen science. NASA's Exoplanet Watch project encourages amateurs to help confirm potential planets discovered by the TESS satellite. Volunteers use remote telescopes to watch for the telltale dimming of a star as a planet passes in front of it. Recently, a team of citizen scientists did just that, providing the crucial data needed to confirm the existence of a warm Jupiter exoplanet, now known as TIC 393,818,343b, and they are making brand new discoveries. The Russian amateur astronomer Philip Romanov used the iTelescope network to discover a near-Earth asteroid in 2024, now designated 2024 QS, by meticulously planning observations with a remote scope in Australia. He's found several others this way. Students are getting in on the action too. In 2014, a group of undergraduates in London discovered one of the brightest supernovae in decades during a routine introductory class. While observing the Cigar Galaxy, they noticed a new bright star that wasn't on any charts. It was the explosive death of a star, SN 2014J. Even the discovery process itself is being automated. In 2023, an AI system named the Bright Transient Survey Bot, or BT's bot, became the first AI to discover, confirm, and classify a supernova entirely on its own, using data from one robotic telescope to trigger another. This frees up human astronomers to focus on the physics, not the grunt work of finding these cosmic explosions. The journey from a sky filled with wonder to one obscured by a self-imposed luminous fog has been a short and regrettable one. We've traded a universe of infinite depth for the shallow comfort of a 24/7 lit world. But the rise of remote telescope farms is a powerful and hopeful new chapter. Through a remarkable fusion of passion and technology, these dark sky sanctuaries are punching a hole back through the veil of light pollution. They are empowering a new generation of stargazers, from the dedicated amateur in a city apartment to the curious student in a classroom, to forge their own connection with the cosmos. Escaping the glow is no longer a dream. It's a service you can subscribe to, a community you can join, a portal you can access from your laptop. These farms are a testament to the enduring human desire to look up and wonder. They are reclaiming our night sky, not by turning off all the lights, but by building brilliant windows of darkness, through which the glorious light of the universe can once again pour in.